some availability where we'll take some questions and answer them. So the IoT4Industry project is a 30-month project funded by Horizon 2020 program of the European Commission. The project aims at accelerating collaboration between IoT solution providers, sensors, communication, big data, artificial intelligence and cybersecurity, etc., and manufacturers through matchmaking and funding opportunities. The project connects 3 information and communication technology clusters having strong competencies in Internet of Things, IoT, clustered together, secured communicating solutions, SCS cluster located in France, microTEC in Germany, DSP Valley in Belgium, and 4 industrial clusters having access to tool manufacturers and manufacturing SMEs, MESAP in Italy, Mont-Blanc Industries in France, Pôle MecaTech in Belgium, and the Manufacturing Technology Centre here in the United Kingdom. So before I get into the project, I'm just going to give you some information about the MTC for those of you who are not aware. So the MTC is part of the High Value Manufacturing Catapult umbrella, and we are one of the 7 centres across the UK. We are located in Coventry, and we also have offices in Liverpool. In total, across the catapults, we have over 2,000 staff, with MTC employing approximately 700 across both sites. And I guess the key takeaway here is that for every £1 of core government funding received, the net benefit to the UK economy is £15. The MTC was established in 2010 as an independent research and technology organisation with the objective of bridging the gap between academia and industry, which we often refer to as the Valley of Death. Our role has also increased to cover not only research and development, but also training, advanced manufacturing management and factory design. We now have over 700 talented employees working with us to achieve our vision, and that's to inspire great British manufacturing. Our focus is to accelerate the UK's industrial growth, deliver innovation, change the way businesses compete, create and embed future skills, and maximise synergies within supply chains. So the IoT4Industry project in a wider context. So what I'd like to highlight here is the project is focusing on 2 core stakeholders, if you like. So the first one is the technology vendor side, which is on the offer, and then the manufacturing side, so primarily SMEs who are in manufacturing, looking at their needs, and as well as promoting IoT amongst manufacturers and getting manufacturers to invest in IoT and start innovating. The project is also looking at training, hence this webinar which we are running today. So what we'd like to do is support manufacturers to deliver high-level awareness training so they can understand what IoT is, what are the benefits, how it can be used, and how they can actually apply IoT. And then we're doing this through support with our technology vendors, and we have 2 of them who will be presenting later on in the webinar. As well as the training, the core for the project is to create collaborative projects to support UK SMEs in applying for funding so they can do their own IoT projects. And that's the core for this project. And later on in the presentation, I'll go through the different funding sources available and how companies can get involved and tap into that funding. So when we began this project, we did some market research where we interviewed 21 clusters spread across 12 countries. So as you remember, we have several partners across Europe. And these interviews conducted covered over 4,000 members, and that was a mixture of manufacturers, IoT providers, and academia. And the reason we did this research is so it allows us to identify technology and application focus areas where IoT technology providers and SME manufacturers are likely to obtain the most benefit from collaboration. So hence why we've been doing this research, so we can understand the problems which manufacturers are going through, but then we can also understand the technology that's available out there to purchase, but also to do innovation with. So from that research, we were able to identify a few key areas or barriers to adoption, if you like. So lack of knowledge and skills with that, as well as lack of awareness, they came out as being on top. And what we found is a lot of manufacturers don't actually have the knowledge to implement IoT, but also truly understand its benefits, and they're not aware of this. And this doesn't just go for high-level management, because when we speak to manufacturers, we notice a lot of the times the directors or the founders or senior management, they understand what IoT can do, but it's the guys that are on the shop floor which are unaware of the benefits. And this is why also culture change is quite high to being a barrier to adoption. And this came across quite clear in our research. And again, we're hoping by doing this training, we're able to promote IoT. We're able to kind of demystify what it actually is, what are the applications that it brings, and how manufacturers can actually start using IoT technologies to benefit them. Cost of investment also came up really high, and this is quite an obvious one. It is, most manufacturers think it's expensive to adopt IoT technologies. However, it isn't as high as we initially thought, and this is now due to a lot of manufacturers understanding that we need to be competitive, we need to start changing, we need to increase productivity, tap into new markets, and the way to do this is through new technology. And therefore the cost of investment isn't as big of an issue as it was before, as maybe lack of awareness is and culture changes right now. Too much legacy equipment. So it's been identified as a common problem that a lot of manufacturers think because they've got too much legacy equipment or old equipment, that it's too expensive or too time consuming for them to start adopting these technologies. Access to IoT, so this is down to there being a lot of technology providers out there, but at the moment it's knowing who to trust, who to go with. And again, it's why we're hoping that this project will broker really good collaboration and conversations between both the manufacturers who have the problems and also the IoT providers who have the solutions. So some key challenges we identified from this. I won't spend too much time and detail going through each one, but lack of competences came out on top. So the cost of training, but then also there's the issue of talent leaving, which came out on top. Regulation, so a lot of manufacturers think it's safer not to actually change, and this can be due to cyber security threats, but also it slows processes in a fast-paced environment. So a lot of the times manufacturers are focusing on what they're doing, and they don't have time to start changing things. Unknown benefits, so the return on investment isn't defined, and it seems very vendor-led at the moment, and there's a lack of example solutions. Transparency, so a lot of IoT providers, who do you trust, and then the reluctance to change the mindset. So areas of focus, as well as identifying the challenges, the key application areas, or the key areas of focus from a technology point of view, were identified. Robotics and automation came out on top, so a lot of manufacturers are looking to implement automation and robotics, so replacing maybe dull jobs and repositioning people within the organization so they can automate certain processes. Sensors, so putting sensors on, retrofitting sensors on legacy equipment to start getting some data, to start using it for information to make decisions on the shop floor, really. So these were the common areas that we identified through our research. So what's in it for me? As I said, the core for this project is the voucher scheme which is available, the funding which is available for SMEs, and that's split into 3 different sections. So there's a feasibility study, which is up to 25,000 per SME, and this will target companies having an idea of an intended project, but it needs further analysing and technical support. So that's the feasibility study, and the maximum lump sum for this project for a feasibility study is €50,000. Then there's prototyping, so up to €45,000 available to do some prototyping, and that will target companies having already carried out a feasibility study and having the need to develop a prototype. And then finally, there's the demonstration / pilot, which is up to €60,000 available per SME, and this will target companies having already developed and tested a prototype with the need to demonstrate its efficiency on a larger scale. So this is the core funding available. And these are the 3 types of vouchers which are available in this first call. So just to give you an idea of the timelines, we'd like people to register their expressions of interest by the 20th of October so we can support in finding you partners, whether it be a manufacturer who's looking for an IoT provider or an IoT provider who might have a solution for a potential manufacturer. We'd like people to attend an IoT training awareness workshop. So this webinar which we are running counts as the awareness workshop. So we're trying to raise awareness for the project, but also IoT in general, and then build a collaborative project. That's the end goal for this, and then to apply for an innovation voucher. So the call for the vouchers has opened on the 20th of September, and it will close on the 20th of December. And then next year it will reopen again on the 10th of March up until the 10th of June. So the time is now to start collaborating and identifying potential areas for projects. So that will conclude the end of my section discussing the IoT for Industry project, and I'm going to hand it back over to our host now, Tim.
Thanks, Eunice, for that introduction. As Eunice mentioned there, the calls are actually open now, and although the expression of interest closes on the 20th of October, it's not essential that you register for that expression of interest, so long as you are aware of the calls for the projects. I'm now going to hand over to Nandini, who's going to cover off the technology awareness. As I said, we will have time for questions later on in the webinar. So if you do have a question, either post it up in the chat session or make a note of it and post it up when we come to the open questions. So I'm just going to hand over now to Nandini.
Good afternoon, everybody. My name is Nandini Chakraborty, and I work within the MTC specifically on the digital manufacturing side of things. So I will talk about Industry 4, smart manufacturing and IoT over the next 15 to 20 minutes. And I would start by saying that Industry 4.0 and smart manufacturing IoT, this is a paradigm by itself. So I'm going to have a literally whistle-stop tour to talk you through what is Industry 4, what is smart manufacturing, what does it actually mean for us, why are we doing it now, what are the technologies that are involved, and what can be some of the use cases or applications of applying some of these technologies. And in terms of the industrial revolution, so there has been 4 industrial revolutions so far. So the first industrial revolution is the Industry 1.0, which is basically the mechanization, steam and water power. The second industrial revolution was coined as Industry 4.0, which is the mass production and electricity. The third one is all about electronics, IT systems, automation. And the fourth industrial revolution, that's Industry 4.0, it's all about cyber-physical systems, and this is where we are. The lines between the physical and the digital technologies are getting more blurred than ever before, and the speed of technological breakthroughs which drive it are unprecedented at the moment. So I think the logical question is, why are we doing it now? And why is the fourth industrial revolution happening now? And what is it different now at this moment, and critically, why is it important to understand it, and how might UMI affect it? There are several key factors driving it, so I will be talking through 4 of them. The first one is globalization, means that we are now more than ever having to compete on a much global scale. We have to be cheaper and faster to stay ahead. The second one is dynamic value networks. What it means is everything is happening quicker. The supply chain and the technology is more dynamic than ever. Businesses need to be able to change in a much more effective manner and to respond to the industry demands in a much more effective and efficient way. The third key factor is jobs and more empowered jobs. People do expect to have better jobs now. They want to be more empowered and to feel that they are adding value or to feel rewarded. The third factor, or the fourth factor, is the untapped potential in data. So in terms of smart manufacturing, in terms of IoT, there are lots of data being generated. So manufacturing in particular generates a lot of data. So how do you use this data to actually get more actionable recommendations or actionable insights from the data? So the next slide is about Internet of Things and what does it actually mean. So these days all of us use smartphones. We have smart TVs at our home, we've got smart watches, smart meters, and even some fridges are termed smart fridges as well. Smart washing machine as well. So what does all these devices have in common? It is connectivity, internet connectivity. So all these devices to a certain extent are connected to the internet. So the connectivity of smart devices are often done wirelessly and over an internet or over the network, and this paradigm is termed as the Internet of Things or IoT. The Internet of Things will be a major contribution to Industry 4.0, and this bit is commonly referred as the Industrial Internet of Things or IIoT. Industrial Internet of Things actually provides the framework for industrial connectivity. So how do we connect the machines? How do we connect the robots? How are factories connected? How can the supply chain be connected, etc.? And all these value can actually provide valuable efficiencies to the overall manufacturing. So how is Industrial Internet of Things different from Industry 4.0? The terms IoT, Industry 4.0, Industrial Internet of Things are commonly used interchangeably and often used to describe the same thing, although there are some subtle differences between them. Industry 4.0, as we have already heard, looks at a range of different technologies or technology enablers which are brought together, and these technologies as a combination can help to transfer manufacturing technologies. IoT technologies form a big part of these technology enablers, in addition to other technologies that we keep hearing commonly: additive manufacturing, 3D printing, artificial intelligence, augmented, virtual reality, cybersecurity, etc. Sorry, having a bit of technical problems. Right, back on. So in terms of what are these technology enablers that I hinted at in my last slide. So there are lots of sensors, sensory devices, instrumentation devices, communication technologies, wireless, wired, cybersecurity. So with this current internet era, so there is a lot of data being captured. Ensuring that we can capture this data in a trusted manner is a key. Artificial intelligence, what it means is actually allowing the machines to actually analyze the data independently and take some autonomous decisions by themselves. Big data and analytics, again, with the volume of data being collected, how do you actually analyze these data to get some insight? Simulation and modeling, how to simulate the virtual physical world, how do you represent the physical world in a virtual environment. Cloud platforms, we keep hearing about different vendors, people like IBM, they have some sort of cloud platforms. Microsoft have a cloud platforms as well. There are a number of different technology vendors now offering cloud platforms. So what does it actually mean? Robotics and automation. So automation has been there for quite some time, but I think manufacturing as such has been quite slow to accepting it. So all these technologies add a big benefit to manufacturing as such. So the next few slides, I will actually dig a little bit deeper into the individual technology enablers. The first one are the sensors. The sensors play a pivotal role in any IoT solutions. The sensors are the devices that provide the raw data that is sent, stored, and analyzed. Sensors can be actually inbuilt in any industrial device, machines, or they can be retrofitted as well to old legacy machines as well. There are sensors for all sorts of data capture, for example, temperature, vibration, imaging, location, etc. The fundamental components of automation of any other systems are the sensors. So the sensors are, in a way, the eyes, ears, and fingers of any system. If the concept of industrial IoT are to succeed, we need more effective, powerful sensors. The leaders in the industrial Internet of Things race may be very well innovators in the development of new sensors, and these sensors are just not technologies, but there will be concepts of energy harvesting and battery management as well. So I just managed to go to the next slide. So the next technology enabler is the communication technologies. So an industrial internet gateway, as seen in this slide, is a physical device or a software program that serves as a connection between the different field devices, and these devices can be sensors, actuators, smart devices, which can be hosted or mounted on any machine or any piece of critical equipment. And it acts as a connection point between the cloud platform and the controllers. So to send data from an IoT gateway to the cloud, a communication protocol is used, and there are a variety of communication protocols that can be used. So all these protocols offer a different sort of value to the developers. Advantages of specific communication protocols can include range, security, power usage, and battery life. So the next hot topic, I would say, is cybersecurity. So in the current era, which is very appropriately termed the digital era, data can be considered as a currency, and as more information and instructions are digitally shared across many platforms between several locations, the risk of unauthorized parties accessing this information is becoming of increasing concern. Digital communication of the industrial Internet of Things use cloud, Internet of Mobile networks, brings many benefits to manufacturing, but also brings in increased security threats. Older equipment, which may have no built-in sensors or no built-in security aspects in mind, there may be gaps in the IT architecture of a particular organization as well. There can be undefined processes and procedures with the failure to conduct appropriate risk assessment, and all these individual elements can add to the security vulnerability as such. The next topic is big data and analytics. So the manufacturing industry creates more data than any other sector at the moment. Big data by itself refers to a very big, large and complex data set which can grow very rapidly due to the fact that the data is often collected from numerous locations, numerous smartphones, smart devices, RFID readers, to software logs, as well as different components within the manufacturing shop floor. Big data is often characterized by 4 V's. So the first V is the volume, that is the amount of data that is collected. The second V is the variety, so this is the number of different sensors can produce data in different formats. Velocity, often the velocity and the speed of the data is very, very fast. Sometimes it can be real time as well. And the fourth V is the veracity, which actually means the quality of the data. So having data in a lot of quantity is not good enough to get any actionable insights. It's the quality of the data which is key. So advanced analytical techniques like artificial intelligence as well as machine learning can provide valuable insights from the data. In terms of one of the most promising applications of big data analytics is predictive maintenance. The last technology enablers that I'm going to talk about is the cloud-based platforms. So cloud-based platforms aim to make certain tasks much easier, and some of them are managing the IoT connectivity, carrying out analytics. You can do cloud-based analytics as well. Cloud platforms can help us in monitoring and visualizing real-time data insights. Cloud platforms can also be used for building business applications. In terms of application areas, so the top 5 expected application areas of industrial IoT is predictive maintenance, which means the ability to predict the maintenance of industrial equipment more efficiently. Instead of being reactive, we become more proactive. The second area is logistic and supply chain, so having a connected supply chain gives us the visibility. Track and trace, so the ability to trace components within the shop floor, monitoring of applications, and process analysis, and this can be, for example, predicting the quality of a part or of a product in real time, or predicting it in advance. And the 5 core relevant topics of industry IoT projects can be smart data projects, smart sensing platforms, connected systems, energy management systems, and robotics and cobotics, which is having collaborative environment where robots can work in a safe environment with human operators. So I am going to pass it on to our host, Tim.
Thank you, Nandini. That's given us a good overview of the technologies and the areas in which they play. And we're now going to move on to the section where we invite a couple of our IoT vendors, and they are covering areas that are very topical in terms of the technologies that Nandini mentioned, which is Brainboxes, who cover off the connectivity and sensors piece, and Sensei, who are a cloud-based predictive maintenance company. Just before we do that, we've got a couple of minutes for some questions. We have a question that was posted whilst the presentation was going on, and that's regarding the registration for expression of interest, and that's being done via the IoT4Industry website. So we'll post that in the chat feed now, and on that there's a innovation vouchers tab, and there are 2 buttons on that tab. One is for posting your collaboration project, and the other one further down the page is for posting your expression of interest. So that's the route into the IoT4Industry project. And Eunice is just posting that on the feed now. What will happen is you will be rerouted to go to a funding box site, which is set up directly for this project, and that allows us to structure the data input and ask the relevant questions, but it is all part of that process. So unless we have any further questions, I'm going to now hand over to